try to imagine a permanent nuclear reaction with energy equivalent to 100 billion 1-megaton hydrogen bombs going off every second. That's what Nobel laureate physicist Hans Bethe proposed in a historic paper in 1939 as the source of the sun's power, whose temperature at the core measures 10 million degrees. All we can actually see of the sun is its surface, where temperatures reach a mere 6,000 degrees. Until recently, its fiery center remained impenetrable. There was no way to confirm Bethe's intriguing idea. Validation of the theory was finally made possible when scientists discovered the means to detect particles called neutrinos emitted at the sun's center as a direct consequence of the primary nuclear fusion reaction. Hurtling to the surface, trillions upon trillions of these invisible particles fan out in every direction, passing through absolutely everything and emerging unscathed and virtually undetected. As the neutrinos go through the Earth, there exists a minute probability that a neutrino may actually hit something, causing a traceable reaction. One of the latest efforts to detect these elusive particles has been underway since 1984 in a tunnel 1,500 meters down under Italy's Apennine mountain range. The great depth ensures that only neutrinos reach the underground lab and that no cosmic radiation penetrates to interfere with any experiment. Rising to the extraordinary intellectual challenge, an international group led by experts from Germany's Max Planck Institute and including scientists from France, Italy, the United States, and an Israeli team headed by Weizmann Institute Professor Israel Dostrovsky have constructed an enormous experiment called GALEX. Their quest is based on the fact that when a neutrino from the fusion reaction hits an element called gallium, it turns the gallium into germanium, which is radioactive and therefore can be detected. Israel's contribution to GALEX originated in the chemistry faculty of the Weizmann Institute of Science. Here, researchers developed the crucial harvesting process that is the key to GALEX, making it possible to actually separate the few atoms of germanium produced by the neutrinos from tons of gallium, the proverbial needle in a haystack. One stage in the experiment calls for water totally free of tritium, the radioactive hydrogen isotope normally found in water. For this purpose, the Israeli team taps a 20,000-year-old underground reservoir discovered by a Weizmann geologist in the Negev desert. All the radioactive tritium has long ago disappeared from this unique source, which remains unaffected by radioactivity from nuclear blasts. Back in Italy, the neutrino hunt starts out here in the underground lab where the radioactive germanium atoms accumulate at the rate of about 1 atom a day in a tank containing 30 tons of gallium. Every 3 weeks, the few germanium atoms that have accumulated are swept out with a stream of nitrogen that transfers them to these columns, where the germanium is reabsorbed in water. The process is repeated until all the germanium is contained in about half a glass of water. The germanium is next converted to volatile germanium hydride, in which form its radioactivity can be measured. It is at this stage that the tritium-free Ice Age water is used to ensure that no background radiation affects the results. The pure sample is introduced into a specially designed counter. In the final stage, the counter containing a 3-week harvest of neutrino-blasted germanium is placed into a sophisticated electronic system where the decay of the radioactive atoms can be observed and tabulated.
We've been running now for a couple of years, and the experiment behaves the way it's been designed. With extreme sensitivity, it enables us to measure for the first time neutrinos coming from the sun and confirm the mechanism of the solar energy production proposed by Bethe way back in '39.
Primitive man worshipped the sun, greeting each sunrise with wonder and each sunset with fear that the light had gone out forever. The sun still dominates our lives, but in our day it has become the focus of study for scientists, seeking to unravel the mysterious workings of the mighty star whose power determines our destiny.